Hi, my name is Asaf Mesika, and roughly about 1 year ago, I started working at StreamNative. And by the way, for those who don't know, StreamNative offers Apache Pulsar as a service. So you know how things are when you start working in a new company. You do the onboarding, a lot of knowledge transfer, and then you need your first task. So I asked Matteo Merli, which is the CTO of StreamNative. So Matteo, do you have any recommended task, to get onboarded? Something small? So he told me, yeah, you can, start by adding support for 1 million topics in Pulsar broker metrics. And I was like, oh my God, Matteo, I wanted something small. Well, it turned out to be big as I thought, even bigger. And I want to share with you today how it's going to make Pulsar so much better for the users and for developers. But before we start, just a quick context about metrics. So Pulsar Broker has an endpoint called /metrics, an HTTP endpoint. Any other component Pulsar has it too. It exposes metrics and their values. Usually you set up Prometheus to scrape that endpoint, and you use Grafana to create dashboard to visualize those metrics. By the way, they look like that. And using that dashboard and visualizations, you can actually know what happens in the broker and in the cluster. So at the first half of the lecture, I want to describe what is the current state, what is the current problems we have today for Pulsar metrics, both from the user experience and the developer experience. And then I'm going to describe to you my proposal to fix it. Let's start with the user experience. First problem is you want to monitor 100,000 topics per broker. Let's do even smaller. You know what? 10,000 topics per broker. Each topic has 100 unique time series. That means that you have combined 1 million unique time series per broker. Now, that's a lot. Imagine you have 100,000 topics per broker. That is 10 million unique time series, unique metrics per broker. The problem with that is that it's expensive, really expensive. You need a very large Prometheus instance or a fleet of instances, maybe Cortex or M3 cluster, or a very expensive vendor. Maybe you want to have a look at it from the namespace level or from a group of metrics level. You have so much data, your queries would simply time out. But that's the situation you have. What do you do? So what everybody does, usually they switch off the topic to namespace granularity. They basically zoom out and view the same metrics on a namespace aggregation level. Or they toggle, and usually they also toggle off the producer level metrics and the consumer level metrics, leaving them quite blind. And when they really need it, what they do is they write scripts on top of the topic stats, which is an HTTP endpoint, giving you very detailed statistics for each topic. And then you take them, you mesh them up, and you combine them, aggregate them, and throw them into a time series database or Elasticsearch. So when you want to monitor so many topics per broker, today you don't have any fine-grained control. It's a all or nothing approach, as you saw, right? That's one really big problem that we need to solve. Other problems that we have is that histograms is a type of metric, and it's mainly used for latencies. The thing is, Pulsar histograms, you can't visualize them normally. Why? Two things. One, the bucket range is not encoded as an LE attribute, as you would expect, as Prometheus expects. And the value is reset to 0 every 1 minute. So if today you have, this is the name, Pulsar storage write latency LE05, it should have been LE equals as an attribute. So when you want to visualize it, you end up having something like that. You want to visualize the storage write latency. Look at the y-axis, it's messages per second. You wanted really something for millisecond latency, like the 95 quantile. This is what you want, but you can't visualize them. Second thing is about rate and summary. Rate and summary are two types of metrics that they reset their value every interval, every 1 minute. So if your Prometheus was down for 10 minutes, you have no idea what happened to those metrics in that period. But if you had cumulative counters or histograms, normal histograms that don't reset, you wouldn't have that problem because you can deduce based on the value after 10 minutes and before what happened like an average. Third problem is that summary is used quite extensively. It's a type of metric. It gives you the quantiles of the previous minute, the 95, the 50 quantile, 75 quantile. The thing is, you can't aggregate them because you can't say, give me, if you know the 95 quantile for one broker and another broker, you can't say, give me the 95 quantile for the entire cluster. You would get an error so big when you aggregate them, you can't really do it. Also, let's say you're writing a Pulsar function. If you want to have your own metrics, and you do, you call this method, record metric, you give the name of the metric and the value. And what happens is that it is translated all those values into a summary of the last minute for all the values you recorded. So you get quantiles of it and sum and count, and it also gets reset every 1 minute. But what you really wanted was a counter, a gauge, an histogram, but you can't. It's always summary. So if you summarize the user experience, you see that you have quite severe issues here. The first and the second are the biggest one. So this was the user experience. Let's take a look at the developer experience. So the developer experience, let's see a couple of problems here. One, it's really, you have multiple ways to define or and record the metric. First one is Prometheus client library. It gives you a gauge, an histogram, a counter, and even a summary, of course. That's one way. Another way, second one, Prometheus has its own metrics library. So stats bucket is for histogram, rate for rates, and its own summary object. Third option, bookkeeper metrics library, which has its own flavors for a counter and a gauge. Also has a special summary for operations. So that's, and the fourth one is native Java SDK, just using atomic long and long header for counters and a primitive long with atomic updater for performance reasons. So you have 4 different ways, and all of them are used in Pulsar. You can imagine as a developer, it's quite confusing. That's problem number 1. Second problem, okay, so you define the metrics and you want to add them to the Prometheus export. So here's what you need to do. Let's say you have that class. And you have metrics in them because you added them, right? You have to have a method called writeMetrics, which accepts a simple text output stream. It's an object. And so in that implementation that you have to write, you read the values of your metrics and you write them as UTF-8 bytes in the Prometheus text output format. And after that, you have to have a call to add a call to it from something called Prometheus metrics generator. As you can imagine, the downsides, that's a lot of work for the developer. And it's our problem. What happens if you forget to add those? And what if you want something cross-cutting, like a shared label for all the metrics? You can't because every class has its own logic for writing the metrics. Another problem is that if you use summary or starts bucket or rate, it basically requires you to write your own method called reset, which calls reset on those metrics. And then you have to schedule a call to that method, find one or create one. The last problem is that there's no way of adding another export format, because the way that it's used today, like the simple text output stream, that UTF-8 bytes in Prometheus format, that's the interface. You can't really add another format on top of that interface. It's simply impossible. So if we summarize, there are multiple issues with the current metric system. Let's see, and the cardinality issue, I think, is the biggest one, the ability to actually know what's going on if you have a lot of topics. So how do we want to solve that? Let's introduce the proposal. The first cornerstone of the solution is use a new aggregation level. And the level is topic metric group. So today we have the namespace aggregation level and topic, and you have to switch between them. It's either one. So now we have something called a topic metric group. It's a group of metrics. And we're going to have each metric that we have today also in topic metric group level. We're going to introduce a new configuration that would allow us to basically define the mapping between a topic and its group. Then when you have that, you reduce the cardinality to something that you determine, because you determine how many groups there are. You can have 10, you can have 10,000. And if you have 1,000 groups, you actually minimize that from 1 million topics to 1,000 groups, from 100K topics in a single broker to 500 groups. And the one before was cluster-wide. So basically, once you have that, the ability to view the metrics in a group level, so you reduce the cardinality and you can decide to zoom in and out. So today, so before that, today we have, let's say, the Pulsar in messages total, and you're going to have that in a topic level or an namespace level. Afterwards, you're going to have 3. Like the same metric is going to have 1 for the namespace level, 1 for the group level, and 1 for the topic level, like 3 distinct metrics. And we're going to have a dynamic configuration that basically allows you to dictate using wildcards which topics belongs to which groups. That's going to be the default implementation. So that solves for us the cardinality issue. But now we still have all those topic metrics. There are a lot. So what do we do? So we introduce something called dynamic filtering. So we ditch all the all or nothing toggles. We're switching to using configuration that basically allows you to control which metrics you would like to expose for each topic, group, or namespace. You decide. And it's going to be rule-based. So that will allow you to define something called, like, for example, a system, like a wide rule that affects everything. And then you can minimize that and override that for specific topics or for specific groups. And it's dynamic, so you can zoom in and out. You can decide to take one group and open it and see it very detailed, and then minimize it again to a group level. So it's very dynamic, like logging levels. Let's have an example. For example, this is the default rule, and I want to drop by default all topic levels and below, like producer, consumer, subscription. So how do we do that? I decide to select to apply this rule for all the instruments that begin with Pulsar and all the attribute sets that have a topic attribute. Okay, that basically the topic level and producer consumer level, right? Have that topic attribute. Like for group and namespace, you don't. And what do we do with it? We drop them all. So basically remaining with the group and namespace level. But now we've diagnosed we have an issue with the receipts US topic metric group. So we need to zoom in. So we add another rule called receipts. and we say, okay, you know what? We have detected that the rate, something is wrong with the rate at that group. Let's open it up. So in the instrument select, we say, okay, for the Pulsar messaging topic, so all the instruments related to the topic aggregation level, what I want to do with them, only for the topics that belong to that group, that have this attribute, I want to filter the instruments. And from all those instruments, I only want to keep the Pulsar rate, the rate in and out, for example. Okay, that allows me to get the rate for any topic in that group. And once I finish the understanding what's the problem, I can fold it back. Okay, let's assume that I want a single topic with the highest granularity. The topic is called BI data. So I'm selecting all the instruments, and I'm saying in the filter, keep all the instruments, everything. Maybe for the topic called logs, I don't want the consumer and subscription level, and the rest I do want. So I can decide in the filter instruments to drop only the Pulsar subscription and the Pulsar consumer. Okay, so we have the aggregation that reduces the cardinality. We have the filtering to get rid of the high cardinality ones, which is the topic, and dictate for each topic or group or namespace which metrics we want, which level, right? But as you can imagine, it's very invasive. So in order to do that, basically what we need to do is to consolidate it into a single metrics library. So how do we, which one are we going to choose? We've decided to choose OpenTelemetry. Now, as Beverly, maybe you ask, why? Why do we want to choose OpenTelemetry? Maybe we're going to ask why not. So what are the options? We have drop wizard metrics. Just a second. Some light. But the problem with drop wizard metrics that it doesn't have any support for attributes, only name and value. We have micrometer. It aimed to be that standard like Cell4J, but for metrics, didn't really happen. But it's only JVM. We also need the Python and Go for the Pulsar function runners. We have Prometheus Java client. That's the only remaining options. But the problem is it's not pluggable. It's only Prometheus. And it has severe performance issues. So it's something that's very hard to fix there. So why OpenTelemetry? First, it's an emerging industry-wide standard. That means that many companies stand behind it. It's actually managed in a foundation, CNCF. That's a really strong thing. But it's not just that. It's going to be an industry-wide standard that people will adopt because it's 10 times better than any other library. And if you read it thoroughly, as I did, you see that evidently. Like, for example, just an example, you can override any metric without changing the code, even the third-party library metrics. You can override, for example, the way the attributes are recorded. You can change histogram buckets using a config, the user config. That's really good. Also, OpenTelemetry is not just about metrics. It's also logs and traces. So you can share context in the future once we switch to it. Being industry standard, meaning that it's easy to integrate a third-party open source library because they really also use OpenTelemetry. And it's very easy to onboard developers or users to configure it, because everybody's going to use it. The maintainers of OpenTelemetry are super friendly. They were really happy to discuss any proposal I had. They actually started fixing real issues that I surfaced there. So I couldn't ask for a better community. Everything is elegant about it. If you read the internal architecture and the design, the specifications, It's brilliant. The idea of using aggregations and views, absolutely brilliant. You can configure how you want to export your values of the metrics, be it delta or cumulative. So if you use Elasticsearch as your time series database, that would be really good for you to use the delta. And it's a super efficient protocol. It has OTLP. Also, the formats are pluggable. So it supports Prometheus OTLP and maybe in the future more. So now that we know why we want to choose OpenTelemetry as the consolidated library, and let's tie it all together. Let's understand what's actually going to change due to the proposal. First, all the names are going to change. Why? Because OpenTelemetry has something called semantic conventions, like an agreed upon way to name attributes and to name even metrics names. Also, we're going to take that opportunity to have a proper domain prefix for any domain. Otherwise, we can't really use filtering. As you may know, the Pulsar broker is a multi-tenant system, not just tenants, but topics, multiple topics hosted on the same process. So when you use histogram for a topic, it's actually misleading when you think about it, because one topic misbehaving cause other topics to look as they are misbehaving, but they actually don't, only because they share the same threads, process, CPU, memory. So we've decided to move the histograms up to the broker namespace level only. Also because there are multiple issues with that in OpenTelemetry. Summaries are gone. We're actually migrating them to histograms. No more rates, only cumulative counters. The rates will be exported, but only through the admin JSON stats. No more all or nothing toggles. You have that fine-grained filtering. The histograms would be correctly exported. And then no metrics will be delta reset anymore. You can decide using the aggregation temporality if it's cumulative or delta, but it's up to you. But inside it won't be there anymore. Pulsar plugin authors, so they're gonna get an OpenTelemetry interface. So they're gonna use that to expose metrics. But that's brilliant for plugins authors, but that means that if you are a user and you're using plugins, you have to update them to use the new OpenTelemetry version if you want to see their metrics in the OpenTelemetry layer, because we're going to add a new layer that's going to have toggles, the old one and the new one. And Pulsar function authors will also get an OpenTelemetry interface, and are going to use basically any type of metric they want, not just summary. All the metrics are going to be properly documented with a rule to force any future added metric to be documented. So those are changes due to the proposal. So where are we in terms of proposal? So the proposal was submitted at the end of April 2023. You can see the issue here. We estimate a rough 9-month effort, but estimates, you never know. We expect it to be available fully by 2024, but we do aim to provide a smaller version, like only the messaging metrics, by the end of 2023. But again, it's up to the way that we decide on the implementation as we go. So I hope you enjoyed and learned about it. And I'm open now for any questions you have until the end of the session. Use the system chat to submit questions. Thank you.